All right, so here we're going to spend a little bit more time talking about calculating frequency and wavelength with the equation C equals lambda nu. So the reason you'll see the units for nanometers pop up again and again in these problems is that the wavelength of light in the visible spectrum tends to be right around the nanometer scale. And so, of course, we like the colors, we like to see the colors, we like to talk about visible light. And so we're going to be doing calculations in the visible light section of the spectrum pretty regularly. Now, for the first question, we are given a wavelength of 240 nanometers. We know that that is lambda. We also know c is the speed of light, which is a constant, meaning we always know it. And we are asked to find frequency. Now we can use c equals lambda nu to get there, but notice this, my wavelength is in nanometers and my speed of light is in meters. So my units are not friends and I can't do algebra with them yet. So I need to make my units friends. The way I'm going to do that is I'm going to convert wavelength from nanometers into meters. I can cancel units the way I can cancel out numbers in a fraction. And so I'm going to put nanometers in the denominator of my next fraction so that they'll cancel out. And I know I want to end up in meters. Now we know that for every 1 meter that we have 1 billion, 1 times 10 to the 9, if you like scientific notation, nanometers. So then I need to take 240, my units cancel, and I need to divide 240 by 1 billion. When I do that, I'm going to get a really small number. I'm going to write it in scientific notation. Because why count all of those zeros when I don't need to? Now I can go back to my equation. C equals lambda in meters times my frequency. How do I isolate my frequency variable? I divide both sides by my wavelength. My units of meters cancel here, and I'm left with units of per seconds here. And remember, a per second is a hertz, which is a unit of frequency. So we're good to go. So I'm going to go to my calculator, 3 times 10 to the 8th, divided by 2.4 times 10 to the negative 7th, and that is going to give me 1.3, if I care about sig figs, times 10 to the 15th. So now let's try the next one. We want to find wavelength, but we're given a frequency. So we still need c equals lambda nu. We know what c is, 3.0 times 10 to the 8th meters per second. We don't know lambda, but we do know nu, and that is 5.31 times 10 to the 14th hertz. Remember, a hertz is a per second, and the reason I'm rewriting it there is so I can double check. Per seconds and per seconds are the same from the speed of light to my frequency. So my units are friends, and I can do algebra with them. So I'm going to take my speed of light equals lambda times my frequency. And then I'm going to divide to get lambda by itself. So this will cancel. And when I do that, divide the speed of light and the frequency, 3.0 times 10 to the 8th divided by 5.31 times 10 to the 14th, I get a really small number. I get that wavelength equals 5.65 times 10 to the negative 7. And because my per seconds canceled out up here, that's going to be in units of meters. Here's the trick though. Recognize this number is very, very small, and I cannot envision how small this number is. And so what I'm going to do is I'm going to convert my units so that my number makes more sense in my brain. I don't really know the difference between 0.000005 and 0.00000005, but I do know the difference between 50, 500, and 5. And so I'm going to convert my meters into a unit that gives me something in the ones, tens, or the 100s range. The way I think about that is I know, according to my negative exponent, that this number is very, very small. So I know I need a small unit. And then from there, I'm going to think about the small units that I know. If I convert this into centimeters, my 10 to the negative 7th will become 10 to the negative 5th. That's still too small. If I convert to millimeters, my 10 to the negative 7th will convert to 10 to the negative 4th. Still too small. If I convert to micrometers, my 10 to the negative 7 will be 10 to the negative 1. Closer, still pretty small. Then I'm going to go to nanometers. From there, my 10 to the negative 7 will convert to 10 to the positive 2. So that's the one we're going to go for, is I'm going to convert this wavelength into nanometers. So I put meters on the bottom because that's what I want to cancel. I put nanometers on top because that's where I want to go. For every 1 meter, I have 1 billion, 1 with 9 zeros, 1 times 10 to the 9th, nanometers. So then when I multiply my very, very small number times 1 billion, I should get, with sig figs, 570 nanometers. And that is my wavelength in a number that makes sense to my human brain.